First, I'll discuss the doubts related to the weekly homework. Exercise 1 of pressure. This was about MCQs. Any doubt from question 1 to 5? From question 1 to question 5, any doubt? If no doubt, then you can just simply mention or write in a chat no. So I'll move on. Question 6 to 10. Any doubt from question number 6 to question number 10? This is exercise 1 of pressure. No doubt. Okay. Then from question 11 to question 15. Okay, question 15. Four physics teachers investigate the pressure. They are wearing identical clothes and lie on a bed of nails. The table gives the weight of each teacher and the total area contact between the teacher and the nails. Which teacher experiences the least pressure? So what you have to do, you have to calculate how to calculate the pressure. Pressure is force acting on unit area. So in this case, as the teacher is lying on the bed of a nail, the weight of the teacher is actually the force. So the first one is 700, the force, divided by area, which is 13. So 700 divided by 13, it is 50. This one pressure is 53.8 Pascal. The second one, because the force or weight is 800 and the area is 20, so 800 divided by 20, you will get 40 Pascals. The third one, the force is 900 divided by area is 15. So 900 divided by 15, that's equal to 64.3 Pascal. And the last one is 1000 divided by 21, which gives 47.6 Pascal. The question is, which teacher experienced the least pressure? So least pressure, you just calculate it. So B is giving the least pressure, which is 40 Pascal. Is it clear? Then from question 16 to question 19. 16 to 19, any doubt? Question number 16, the diagram shows three different containers, J, K, and L. Each container contain a water at the same depth. Which statement about the pressure of the water on the base is correct? As you know, the pressure exerted by the water depends on the density of the water, it depends on the gravity, and it depends on the depth. So when you check, they mention each container having a same depth and all are filled with water. So if all are filled with water, they will have the same density and they have the same depth. So if depth of J or depth of water in J is same as depth of water in K and it is same as depth of water in L. So if all have the same depths and they are filled with the same type of a liquid, so what we can say about the pressure, we'll say the pressure exerted by liquid J at the base is same as pressure exerted by liquid K, and that is same as pressure exerted by liquid L, because they are asking for pressure exerted by the liquid. Pressure of the water on the base of each container. They are not asking about pressure exerted by the container. The pressure exerted by the container will be different on different surface because they have different base areas. But pressure exerted by the liquid does not depend on the type of a container. It depends on the density of the liquid which we have, and it depends on the depth of the liquid. So all the liquids are identical, so they have same density. All the liquids have the same depth, so that's why the water pressure is same in all three containers, or pressure exerted by the water or liquid is same in all three containers. Is it clear? Any other doubt from question 16 to question 19? In question 18, a drawing pin or a thumbtack has a sharp point and a flat end. The pin is pushed into a wooden board. So if I apply a force of 30 Newton, how much force will be there other side? The force will be same. That force will be 30 Newtons. So if I apply a force of 30, the same force is applied on the other side. But what about the pressure? About the pressure, we know pressure is force divided by area. So the sharp point is having a small area. So if it's having a small area, means it will apply greater pressure, or it will apply more pressure. That's so that this thumbtack or a drawing pin can stick to this wood. So how do the pressure and the force at a sharp point compare to the pressure and the force at the flat end? So force at the sharp point will be same as, because if we apply a force of 30 Newton, same amount of force is applied to other side. So force will be same, but what about pressure? Area and pressure are inversely proportional. So if the part is having a small area, it will exert more pressure. So pressure at a sharp point will be greater, but the force will be same. So they have the same as the flat end, but the pressure at the sharp will be greater than the flat one. That's why C will be the correct or the right answer. When the atmospheric pressure increases, so if the atmospheric pressure increase, what happened? The level of the liquid will change, because atmospheric pressure applied from this side, so it will push this X down. So X will go down. And what happened? W will rise up. They are saying which distance increases? V and W. So V and W, it will not increase, it will decrease, because the W rises up. So distance between V and W or W and V will decrease. W and Y, so Y is fixed and W is rising. So what happened as it increase? So distance between Y and W will increase. What about X and Y? Because X is going down. So as X is going down, the distance between X and Y will decrease. And X and Z, as X is going down, so distance between X and Z will also decrease. So answer is B, which is W and Y. So distance between W and Y will increase. This was exercise 1 of topic pressure. Now exercise 2. Any doubt in question 1? Mention the question in which you have doubt from exercise 2 of pressure.
Sir, in exercise question number 1, B.
Okay.
Sir, is like it mentioned in the mark scheme the friction of the hinge. I just want to know how it acts.
Okay. First, we have to calculate a pressure on the lid due to a seawater. So how to calculate a pressure due to a seawater? The formula to calculate the pressure due to liquid, pressure is equals to density multiplied by gravity multiplied by depth. Density is given 1020, gravity is 10, and at what depth? Because it is at a depth of 15 meter. So this will be at a depth of 15 meter. So you will multiply them, you will get the answer. Then the total pressure on the lid. What is the total pressure on the lid? What happened? Because it is inside the liquid, so there is a pressure due to liquid. And outside, there is atmosphere, so there is a pressure due to atmosphere. So if I need the total pressure on this lid, so what is the total pressure? The total pressure on the lid is equals to pressure due to the liquid plus pressure due to atmosphere. So you will add both pressures, you will get the total pressure. See, and the atmospheric pressure is given in the question. You can see it's given 1 exponent 5 or 100,000 Pascal. So this is the atmospheric pressure, which is 100,000 Pascal or 1 exponent 5. And the pressure of the liquid you already calculated in the previous part, which was 1020 multiplied by 10 multiplied by 15. For the next part, the downward force. So after the downward force that the total pressure produced. So after getting a total pressure, like your answer here was pressure due to liquid, which is density into gravity into height. Density is 1020, gravity is 10, and the depth of the liquid was 15. What was this answer? Pressure due to the liquid,
Sir, 153,000.
153,000 Pascal. Then you need a total pressure. So total pressure is actually the pressure due to atmosphere plus pressure due to liquid. So what is the pressure due to atmosphere? The atmosphere is pressure is given in the question 1 exponent 5. This value is given plus the pressure due to liquid. So it is 153,000 Pascal. When you add, you will get the total pressure. So total pressure is, just add these two numbers. So it will be 253 and 253,000 basically. The rounded off in marking scheme, most of the answers are in rounded off or rounded off to nearest number, whole number. That's why it's written 250,000 Pascal or 250 kilopascal, but it's the actual one is 253,000 Pascal. Next, we need a downward force. Look, in this question, the first they ask the pressure due to liquid. So how to calculate a pressure due to liquid? The formula to calculate the pressure due to liquid is equals to density of the liquid multiplied by gravity of the liquid gravity multiplied by depth in which the object is there. So density into gravity into depth, you will get the pressure due to liquid. So density of a liquid is 1020, gravity is 10, and the depth is 15. So when you multiply, you will know how much pressure is exerted by the liquid. So it will be 153,000 Pascal when you multiply all of them. Then they are asking find the total pressure. So total pressure is due to liquid plus atmosphere. What is the atmospheric pressure? That's also given in the question, 1 exponent 5. So 1 exponent 5 or 100,000 Pascal. So 150,000 is there, or 153,000, and 100,000 Pascal is there. You need a total pressure. So if you need a total pressure, the total pressure at the top is due to the pressure of the liquid plus pressure of atmosphere. So the total pressure is equals to pressure of the liquid plus pressure of atmosphere. Pressure due to the liquid you already calculated in the previous part, which is 153 and 3 zeros, plus pressure of atmosphere is 100,000 Pascal. When you add these two values, what you will get? You will get the total pressure which is due to the liquid and atmosphere, which is 253 and 3 zeros Pascal. Is it clear? This is the first part. First A1 and A2. This is the answer for A1 and this is the answer for A2. Next, we need a force. So how to calculate the force? The area is given. Basically, length and widths are given. So one is 1.2, another one is 0.8. So we have the pressure formula. Pressure is force over area. So if I need force, so force is equals to pressure multiplied by area. Pressure is 253,000 Pascal. And what about area? Area of this lid, because length is 1.2 and the width is 0.8. So when I multiply length into width, I'll get area. So area will be 1.2 multiplied by 0.8. So when you multiply these all, the pressure with the area, you will get the force. So what is the force? It will be about 240,000 newtons approximately. Is it clear? That is the force which this object will experience. And then in the next part, they say the force needed to open the lid is not equal to the value which we calculated. Like example, if this is a box, this is a box and there is a lid on the box. So box is there with a lid and this is a hinge where you can like open this. So box can be opened in this manner. So the force on the box, as we calculated, the force on the box is 240,000 Newton. This is the force which is acting on this box. It's about 240,000 Newton. Now, in the question, if we want to open this box underwater, the force needed to open the lid is not equal to the value which we calculated. According to theoretical value, if the force acting on the box is 240,000, so I should also apply a force of 240,000 so that I can open this box. It will be a bit more than 240,000, but the theoretical assumption is the force required, like if object is there, if I want to lift the object, the force is equals to weight of object. Same thing, if I want to open the object, open the lid, so the downward force is there, which is closing a lid, should balance with the upward force, or upward force should be a bit more than the downward force, so that we can open this lid or a cover. So if the downward force is 240,000, the upward force should be approximately 240,000 or more than that. But practically it's not same. So why practically it's not same? What is the reason for that? There are many reasons. Number one, maybe this box contain air. So if this box contain air, what happened? The air molecules are moving randomly. So this air molecule might push this upward. So if air molecule is pushing this upward, then I don't have to apply too much force. I can apply a small amount of force so that I can open the lid. So in that case, if there is air inside the box, air molecules will apply an upward force. So I don't have to apply the same amount of force which is downward. I have to apply a smaller force. Another thing, maybe there's a friction. What is the meaning of a friction? The friction always opposes the motion. We also call, so maybe there's a friction here. So this friction resists the movement of this lid. Friction does not allow the lid to move easily. So if friction does not allow the lid to move easily, example, if there is a friction for 100 Newton of 100 Newton, then what happens? I have to apply extra force to overcome the friction as well. So there are many reasons, possible reasons why the force required might be different. What is a downward force? Because there may be a friction which resists the movement of the lid, so we have to apply a greater force. Or maybe it contains some trapped air, because air is moving randomly. As air is moving randomly, it apply a pressure which make us easy to open the lid. So these are some reasons why the force which we calculated and the force actually we required to open the lid may not be same. Is it clear?
Yes, sir.
Any other question, any other doubt in this exercise 2 of pressure? Question 6, page 6, question 5b. Look, in this question, figure 3.1 shows a hydraulic lift in a car repair workshop. The hydraulic fluid transmit the pressure that cause a piston A equally pressure to other side. So first, when you calculate a pressure, pressure is force acting on unit area. So if you apply a force of 1000 Newton, so force is 1000 Newton and area is 0.01. So 1000 divided by 0.01, so it will be 100,000 Pascal. And according to Pascal principle, if we apply a pressure of 100,000, same amount of pressure is applied in all the directions. So the same amount of will be applied, that's equal to 100,000 Pascal. But what about the force? The force will be different. Area of each is 0.2. So pressure divided by area 0.02. So you will get, sorry, not divide, multiplied, because we need a force. So pressure multiplied by area, which is 0.02. So what you will get? You will get 2000 newtons. So the upward force, each piston is applying an upward force of 2000 Newton. So total upward force is 8,000 Newton. That's a total upward force. The weight of the each car support dimension, in the question, it's 1,000. So the car support weight is acting down and weight of the car is also acting down. So 1,000 Newton because of first car support, 1,000 because of second, and weight of the car is also acting down. So downward force is a weight of the car plus 2,000 Newton. That's a combined weight of the two car support. As it is balanced, it is stationary. So it means that the upward force is equals to downward force. So the upward force is 8,000. The downward force is 2,000 plus the weight of the car. So it's 2,000 is added, other side it will subtract. So the weight of the car is 6,000 Newton. But in the question, they asked for mass of the car. So you have the formula W is equals to mg. So weight of the car is 6,000. Mass of a car we don't know, and the gravity is 10. So if 10 is multiplied, other side it will divide. So 6,000 divided by 10. So what is the mass of this car? The mass of this car is equals to 600 kg or 600 kilogram. Is this clear? That is how we get the mass of this car. The total upward force, each piston is applying an upward force of 2,000 Newton. The weight of the car is acting down. The downward is the weight of the car, which is acting down. And the weight of the car support, they also mentioned that is also acting down. And weight of each car support is 1,000. So as it is balanced, the upward force equal to downward force. The forces which are acting up must balance with the forces which are acting down. So upward force 2,000, total force is 8,000, and the total downward force 1,000 for each car support. So two car supports are there. So that's 2,000, and weight of the car is also acting down. 2,000 is added here, other side it will subtract. So the weight of the car is actually 6,000 Newton. But in the question, they did not ask for weight of the car, they asked for the mass of the car. So weight is equals to mass divided by gravity. So it will be 6,000 divided by 10. It is equals to 600 kilogram. So weight is mass multiplied by gravity. So mass is equals to weight divided by gravity. So weight is 6,000 and the value of the gravity is 10. So 6,000 divided by 10, it's equal to 600 kg. How I got 8,000? Because when you solve this part, the total upward force, so when you calculate the pressure exerted, you were applying a force of 1,000 Newton. So what is the pressure? Pressure is force divided by area. So force you are applying 1,000 and area is 0.2, 0.02. Sorry, 0.1, 0.01 for this one. So 1,000 divided by 0.01, that's equal to 100,000 Pascal. That is the pressure which you apply. According to Pascal principle, the liquid will apply same pressure. So if the pressure is 100,000 and area of one is 0.02. So 100,000 multiplied by 0.02. So that will give us 2000 Newton. So force, the upward force by each piston is 2000. So for piston 1 is experiencing 2000 upward, 2000, 2000 and 2000. So when you add this all 2000s, you will get 8000. So the total upward force is 8000. And the weight of each car support, which is 1000, and the weight of the car is acting down, that's unknown. So you will solve and you will find the answer that's equal to 600 kilograms or kg. And in question number 2, a rectangular container has a base, a dimensions are there, 0.12 and 0.16. The container is filled with a liquid. The mass of a liquid is 4.8 kilogram. What is the weight? So how to find the weight? Weight is mass multiplied by gravity. So mass of the container, mass of the liquid was 4.8 and the gravity is 10. So 4.8 multiplied by 10, it will be 48 Newton. What is the pressure? So here you have area and you have weight. So you can calculate pressure. Pressure is force divided by area. The force is equals to weight, which is 48. And how to calculate the area? Its dimensions are given 0.12 multiplied by 0.16. So 0.12 multiplied by 0.16, when you multiply these two, you will get the area. Then explain why the total pressure on the base is greater than the value which we calculated. What is the reason for that? Why in reality the pressure will be higher as compared to what we calculated? Because what happened for a liquid, not only there is a pressure due to liquid, but there is a pressure due to atmosphere. We only calculated the pressure which is exerted by the liquid. But in reality, why the pressure will be higher? Because there are total pressure is a sum of the liquid pressure plus atmospheric pressure. So when we add, we'll get the total pressure. So in reality, the pressure exerted or pressure experienced by the object which is underwater is higher than as we calculate, because we only consider the pressure is due to liquid. But in reality, the total pressure is due to liquid plus the atmosphere. Is it clear? And then calculate the depth. The depth of a liquid is now calculate the density. How to calculate density? Density is equals to mass divided by volume. So mass was given 4.8. And how to get the volume of a liquid? Its length into width into height. Length and width are given at same as a container. So 0.12 into 0.16 into 0.32. So 0.12 multiplied by 0.16 multiplied by 0.32. So when you multiply all these factors, you will get the volume. Mass divided by volume, you will get the density. Any other doubt in this exercise 2 of pressure? some questions related to energy topic. Randomly, I will take the question so that you have understanding. Question 24. What could be the answer for question 24? What are the main energy changes that take place in hydroelectric power station? Everyone should participate to show understanding. Even your answer is wrong, that's not an issue.
C.
So because hydroelectric power station, the water is at certain height, it will have gravitational potential energy. When it moves, changes to kinetic and then rotate the turbine, produce electricity. In which pair, question 26, in which pair energy sources are both renewable? Tidal is the high and low tides. It's also the wave energy.
C. Tidal and geothermal.
Tidal and geothermal are the renewable. Yeah, that's right. What need to know to calculate the work done by a force? How we can calculate a work done? What we need to calculate a work done? So to because the work done is a product of force into distance. So we need a force, we need a distance, but we don't need time. If it was power, we need all of them. Because power is work divided by time. So that's why we need time as well. Electrical energy may be obtained by nuclear fission. In which order the energy is this energy transfer in this process? What could be the answer? So first we have a nuclear fuel. Then we have reactor and boiler, which convert water to steam. Steam rotate the turbine and turbines are connected to generator coil, which produce electricity. Question 31. Some energy sources are reliable and available all the time and some are not. Which three sources all in their correct columns? Available all the time means anytime you can use that energy. It does not mean renewable or non-renewable. Like even day and night also you can use that energy. So what could be the answer for this? Yeah, B is the right answer. Because solar energy is only available